Guzazampo, welcome to our maths tutorial programme. Today we're going to be looking at the concept of area. Have you ever stopped to think about how area is a common problem that is used all around us? Well, that's what we're going to be looking at today. Let's start off by thinking about what area actually means. Area relates to how much space a 2D shape takes up on the ground. So let's have a look at some examples of that. If I look behind me down into Timpu, we can see that we've got the helipad landing site. We can see that the area of that helipad landing site is the actual physical amount of space that is taken up on the ground by the concrete. Let's move over now to have a look at another example, the football pitch, which is in fact a rectangle. The actual space that the football pitch takes up on the ground is the area of the football pitch. And a final example, let's move across to have a look at the athletics track. The actual space taken up by the athletics track on the ground represents the area of that athletics pitch. Okay, so let's start off by having a look at what area actually means mathematically. And to do that, we're going to go back to basics. So first of all, let's have a look at our line. This line only has one dimension. So this is a one-dimensional object, 1D. And the one dimension that this line does have is a length. We can measure this length in a number of units. I am going to select the units for measurement today as centimetres. So a one-dimensional shape is a length, and this is measured in either centimetres, metres, feet, and there are a number of ways to measure this line. Now let's have a look at a different shape, our two-dimensional shapes. And I'm sure that we will all know a number of two-dimensional shapes. Squares, rectangles, circles, trapeziums. In fact, any polygon falls within this area. Two-dimensional shape. Two dimensions because it has two dimensions. This one has a base and it also has a height. Two dimensions. Hence a two-dimensional shape. So what we measure with two-dimensional shapes is area. Area relates to two dimensions. So if we were still using centimetres, we would need to measure in centimetres squared. Two dimensions, centimetres squared. So that's how we know that area relates to a 2D shape, and we measure it in whatever units we are looking at, feet, centimetres or metres, and that has to be a squared unit. Firstly, let's have a look at how area fits into the world of construction. Let's say that you are building your own house and you have designed your roof and you need to know how much CGI you need for your roof. This is a very typical area problem. Most roofs in Bhutan are built on three different shape structures. We have rectangles, triangles and trapeziums. We're going to have a look at those three shapes now and see how we can calculate the area so that when you are building your own home, you can work out the area of CGI that you require. So let's start off with a simple roof shape of the rectangle. How do we calculate the area of a rectangle? There are 4 areas that we need to be able to calculate: the rectangle, the parallelogram, the triangle, and the trapezium. So, calculating the area of a rectangle. We've been told in school that the area of a rectangle is base times height. But let's try and work out why that might be. If we divide our rectangle into small squares that are 1 centimetre square, if we counted them, we could see that we had an area of 18 squares. 6 columns along the bottom and 3 rows up the side. So 6 times 3 is 18. And that is why we say that it is base times height. So we need to also be able to calculate the area of a parallelogram. And we've told again in school that this area is base times height. But this is the same as a rectangle. How can this be so? Let's have a look. If we make a cut on our parallelogram as shown on the graphic, and we move that to the other side, we can see that in fact what we have made is a rectangle. The rectangle has the same base as our original parallelogram. And of course the height is the same. So that is why the area of the parallelogram is base times height. The roof that we're going to look at first, the rectangle, is this roof here that we've been examining in the Timpu Valley. This is an example of a rectangular roof structure. So we have taken rough dimensions for this roof and we have drawn a model on the whiteboard. So let's have a look at that now. The dimensions for the roof that we have been looking at are 5 metres high by 15 metres long. So this rectangle has a base of 15 metres and a height of 5 metres. So we know that to find the area of a rectangle, we need to use the formula base times height. So our base is 15 metres and we need to times it by our height of 5 metres. So without a calculator, let's do that now. So 5 times 5 is 25, carry the 2, 1 times 5 is 5, add the 2 is 7. So the area of CGI required for this roof is 75, and we were initially measuring in metres, and as we know it's a 2-dimensional shape, so we need to measure the area in metres squared. So that's the rectangle, fairly simple. So the next roof that we are going to look at is made up of 2 different shapes. The first shape that the roof is made up of is the triangular shape, and there are 4 separate triangles that make up that top portion of the roof. The second shape that makes up that roof is the trapezium, and that is the bottom portion of the roof. And we have 4 trapeziums that make up that bottom portion. Quite complicated, but we can break it down mathematically to work out the area of CGI required for this roof. Firstly, let's have a look at the triangle. Now, can we remember how to find the area of a triangle? To find the area of the triangle, we are told in class that it is base times height divided by 2. Well, we know that base times height is a rectangle, but why is a triangle half of that area? If we make a cut from diagonal corners on our rectangle, we can see that we are left with a triangle. So in fact, a triangle is exactly half of the rectangle. And that is why we have the area of the rectangle and we divide it by 2. Let's see how that relates to the triangles we're going to be looking at today for our roof structures. If we make a rectangle around the triangle that we are looking at, then the area of this whole shape will be base times height. But we've got these bits left over, this bit here, and this bit here that we're not using. If we put them together, we can see that again they make up another triangle. So in fact, we have again got double what we need, which is why it's the area of a rectangle divided by 2. Now that we know how to find the area of a triangle, let's have a look at working out the area of the triangle in our roof. And that triangular portion of the roof has a base of 4 metres and a height of 3 metres. So we know that to find the area of a triangle, we need to do base times vertical height, which we have in this case, and divide that by 2. So our base times our vertical height divided by 2 is the same as 12 divided by 2, and the area in this case is 6. We were working in metres, and because it's an area, a two-dimensional shape, the units for our area will be in metres squared. Now, one last tricky stage for this roof. We already said that there are 4 triangles that make up the top portion of that roof. So to work out our total area of CGI required for the triangular portion, we need to take our area and times it by the number of triangles that we have. So the total area that we require for the triangular portion of the roof is 24 metres squared. So let's have a look at the next shape now that's required in the roof. The bottom portion of the roof is made up of trapeziums. Trapezium is a complicated shape as we look at it. Trapezium means that there are 2 sides that are parallel only. If we were to look at a rectangle, we can see that we have 2 pairs of parallel sides, but the trapezium has just 1 pair of parallel sides. So how do we work out the area of a trapezium then? Trapeziums have these 2 parallel sides. If we cut our trapezium in half, remove the top portion, rotate it and place it next to the bottom portion, you can see that we have a shape with exactly the same area that we started with, but it is now a parallelogram. The height of the parallelogram is half of what we started with, which is why it is the height of the trapezium divided by 2. And the base measurement for our parallelogram is the sum of the 2 parallel sides of our trapezium, A plus B. So this is why the area of a trapezium is A plus B, which is the base measurement, multiplied by half the height, which is the height measurement. Now that we know how to find the area of a trapezium, let's do it for our example roof. So we have taken the measurements of the trapezium, which is the bottom portion of the roof, and we know that this trapezium has a base length of 8 metres, a top length of 5 metres, and a vertical height of 4 metres. So, as we know, the first thing we need to do is add together our 2 parallel sides and multiply that by half the height. So 8 plus 5, and then we are going to multiply that by half of the height. So let's work this through. 8 plus 5 is 13, and we're going to multiply that by half the height. 4 divided by 2 is 2, and 13 multiplied by 2 is 26. And we know again that we're working in metres. It is a 2-dimensional shape and it's an area, so our area units are going to be in metres squared. Now, we said, if you remember, that we have got 4 trapeziums making up the bottom portion of that roof. So we need to take our area for one trapezium and multiply that by the number of trapeziums that we have in the bottom portion of that roof. So we will need to do 26 multiplied by 4 trapeziums. 6 4s are 24, carry the 2. 2 4s are 8, add the 2, makes 104. So again, we are still working in area. So the area of CGI we would need to make that portion of roof made up by trapeziums is 104 metres squared. So the last thing that we need to do is add together our two areas to find a total area of CGI that we require. So if I add 24 metres squared to 104 metres squared, the total area that I get is 128 metres squared of CGI required to make that roof. We are here in the Kunga Zongkang hardware shop in Thimphu, and we've come to find out how much it will cost us to buy the CGI for our roofs. The first roof that we are going to look at is the rectangular roof. The rectangular roof, if you remember, we calculated, had an area of 75 metres squared. And the roof has two portions, so we've doubled that area to find out that it has an area of 150 metres squared. Now we should say that for construction purposes we have simplified this example, and we have taken into account slope and overlap to simplify this example. So we're very lucky to have the shop owner who's going to explain to us how to cost our CGI sheets.
So since you have already done the slopings and overlapping, so it's very simple for us now. Only we have to take the length and breadth into account and find out the area of one slope of the roof. CGI sheet usually, as per our practice, comes in a bundle. Bundle is the total area of the bundle without corrugation is much higher, but after corrugation, the CGI sheet roofs are corrugated. So after corrugation, it's 180 square feet in a bundle. So our unit of trading is in bundle usually.
So that's another good mathematical problem, isn't it? Because we have done our calculations in metres squared, and the bundles are measured in square feet. So that's another good bit of maths that we can work out there.
Yes, we have to take this one into account, because 75 meters square means into 10.764 square feet.
So if we can just write this down to make this clear for those that are watching at home, you just told us that 1 metre square was the same as, you used a conversion of
10.764 square feet.
764
square feet.
Square feet.
Yeah. So
to convert our metre squared measurement into square feet, we took 150 and we multiplied it by the conversion.
Yes,
so
10.764, I'll just do this one particularly for you, 1614.64 square feet.
Perfect.
Yeah.
So now we have...
So we have square feet requirement of your CGI sheet. And another thing we have to, maybe this one is not a problem of mathematics, but it's a construction practical problem. So because we cannot lay the CGI sheet end to end, but we have to keep some overlapping so that the rain won't leak. Otherwise, 1614.6 divided by 180 will be our requirement. So we need 8.92 bundles of CGI sheet. And what is the present cost? You can multiply this one.
So we did the total area that we require divided by the area in a bundle.
In a bundle,
yeah.
Yes, that's exactly what.
Which in our case was 1614.6 divided by 180, and we found that we require a total of 8.97 bundles.
You probably need a bit more than this one, because we didn't keep the provision for overlapping.
The provision for overlap. So it would be somewhere in the region of 10 bundles.
10 bundles, yes.
10 bundles?
Yes.
For this roof. Thank you so much. Shall we take a look at our more complicated second roof?
Yeah.
So now we're going to try and work out how much CGI we need for our second roof. The second roof, if you remember, was much more complicated because it consisted of triangles and trapeziums in combination. So we've written down the areas that we calculated when we were looking down on the roof. If you remember that the area we calculated for the triangle was 6 meters squared, and because there were 4 of them making up the top portion of the roof, we multiplied that by 4 to get 24 meters squared. And the trapezium, if you remember, made up the bottom portion of the roof. It had an area for 1 which was 26 meters squared, and because there were 4 sections, we multiplied by that one by 4 to get 104 meters squared. So we have our 2 areas in meters squared, and I've written down the conversion, and please, if you would be able to tell us how it's different this time to work out how
From
much
the
CGI
previous
we
ones,
need.
yes. You can cut CGI sheet in such a way that the piece you cut from here can be reversed and put it the other way, so that from here, whatever piece of CGI sheet you cut, you will cover the longer area this side. So total you will be buying only this much, whatever you have calculated exactly. And in case of this one also same thing, because whatever we cut from here 4 meters, and the axis cutting from here can be joined to the other side, the longer side of the roof. And the only thing we have to remember is the provision for overlappings, sidewise and lengthwise. So only this one you have to add. So some percentage you can add onto your roofing thing.
Great.
Great.
So if we follow through the process that you taught us before, would we find a total area for the 2?
Total area will remain the same, because
So
you have calculated exactly what
excellent.
it is.
So our total area here, which we did earlier, is 128 meters squared.
Yeah.
So if I convert that to feet,
Okay.
I take my 128
meters square times 10.764 square feet is equal 1,377.79
to feet
square.
squared.
Yeah.
And then, as we did before, we divided that by the total
By
area in
the
a bundle,
total
didn't
area
we?
in a bundle, 180.
So the number of bundles we require,
Will be 7.6544.
I'll just write out what we're doing. 792 divided by the
180 square feet.
180, which is the area in a bundle,
Yeah.
and we get 7.654 bundles. And to allow for overlap and so on, we would be looking at 9
Yeah.
bundles.
On the safer side, 9 bundles. Yes.
That's perfect. Thank
Yeah.
you so
Okay.
much.
Okay.
A compound shape is a shape that's made up of a combination of these recognisable shapes. An example of where we may apply this problem is if we were trying to find the area of our floor in one of the rooms of our houses. If we were going to try and cover it with carpet or wood, we would need to find the area so that we could then buy the correct amount of carpet or wood. So we are going to have a look at one of these problems. Here we have a layout of the floor of a room that we are going to carpet. And we have taken our measurements in our room and measured each side so that we can begin to calculate the compound area. The first thing that we can recognise is that we can't straight away find the area of this shape because it's compound. So what we're going to do first of all is we're going to break our compound shape up into shapes that we can recognise. 2 rectangles and a triangle. And we know how to find the area of those shapes. So we're going to complete the dimensions that we need for each of those individual shapes. And when we've done that, we can break up our compound shape to look at 3 independent recognisable shapes, 2 rectangles and 1 triangle. So if we look at the triangle first, we know that to find the area of a triangle, it is base times height divided by 2. So you can see that we've done that in this case, 5 times 3 divided by 2, and we've found that the area of that triangle is 7.5 metres squared. We did the same for the first rectangle. The area of the rectangle is base times height, and we've times 5 by 3 and got 15 metres squared. So we know the area for that portion of the compound shape. And the final rectangle, we've worked out the area in the same way, base times height, which is 6 times 3, and we found that the area of that final rectangle is 18 metres squared. So to find the total area of the compound shape, all we need to do is piece those individual shapes back together again and add up all of the individual areas. So we've got 15 metres squared plus 7.5 for the triangle plus 18 for the rectangle, and that gives us a total area for this compound shape of 40.5 metres squared. And with that knowledge, we now know the area of the floor of our room and therefore how much carpet or wood we will need to buy to cover it. During this programme, we have learnt all about what area means and that it relates to a 2D shape, and because there are 2 dimensions, that means that we must have a square on the units that we're using, whether that's metres, centimetres or feet. We have looked at a number of different shapes, the rectangle, the parallelogram, the trapezium and the triangle, and we now know how to find the area of all of these shapes. And we have related that to working out or calculating the number of CGI sheets that you need to build a roof that is any shape or size. I challenge you to now use the skills that we have learnt today to go and help one of your friends or relatives in their building projects or area problems and see what you can do to help them.